Here we have an equation with an x under the radical and an x not under the radical. When that happens, we do have to get rid of the radical first and see what happens. And before we can get rid of the radical, we have to make sure it's all by itself. In this example, the radical is already all by itself on the right side of the equation. So I just need to get rid of it by using a power, the correct exponent. And that power should always match whatever this index is. And as you know, if there's no number written there, the default value is 2. So I'm going to start this off by squaring both sides. And that means the left side is simply x squared, and the right side square and square root cancel, leaving me 3x plus 28. The resulting equation has an x squared term, an x term, and a constant. That makes it a quadratic, which means we really want to get one side equal to 0, and the strong recommendation is to always keep the x squared term positive. So I'm going to actually move this to the left side and this to the left side by subtracting 3x and subtracting 28 to get x squared minus 3x minus 28 equals 0. These will typically be factorable. If you like to factor, go ahead and try that out. If it doesn't work or if you don't like it, you can always use the quadratic formula. This does factor though. X and x can multiply to make x squared. To get a negative 28, I could use a 7 with a 4, and the 7 and the 4 combine to make negative 3 if the 7 is negative and the 4 is positive. That's going to equal 0. And since x minus 7 times x plus 4 only equals 0 if this or this is 0, I got to figure out what makes x minus 7 equal 0. X minus 7 is 0 if x equals 7. Then I got to figure out what makes x plus 4 equals 0. That equals 0 if x equals negative 4. These are my two possible answers, but I do need to go back to the original equation of x equals square root of 3x plus 28 with both of these x values and make sure they work. If they don't work, I cross them off. If both cross off, there's no solution. We'll start with the 7. If x equals 7, then this becomes 7 equals the square root of 3 times 7, wow, plus 28. Alright, seems like a lot. Let's do the inside of here. 3 times 7 is 21. 21 plus 28 is 49. So 7 equals the square root of 49. And of course, the square root of 49 is 7. 7 equals 7 is a true statement. I'll keep that answer. Now for this negative 4. If x is negative 4, then this equation becomes negative 4 equals the square root of 3 times negative 4 plus 28. Looking inside of this grouping symbol, 3 times negative 4 makes negative 12. Negative 12 plus 28 makes positive 16. So we get negative 4 equals the square root of 16. The square root of 16 is positive 4. So I end with the statement 4 equals negative 4, which is not true. They're not equal. They're opposites. So this is actually not an answer. So even though all my math here is correct and I got both of these to be answers, the actual only answer is x equals 7. So you definitely have to check those answers and cross off ones that don't make true statements. Good luck.